So this is kind of a general YSU 1510 review. So it should cover most of what we have done so far or in the course. So I'm going to get through as much as I can. Obviously, I'm not going to do every problem, but I'm going to kind of pick out some of the ones and give you some strategies to look at. Okay, so let's start with problem number 1. And problem number 1 says to find find all real solutions. So for these ones, if you get to a point where there might be a complex like an I in there, you don't have to go any further. Let's just start and look at a few. Problem number 1C and 1J and kind of 1I are very similar types of problems. Let's just look at a strategy that you would want to take. For 1C, to get rid of that square, you're going to square root both sides. And remember, when you square root the 16, you're going to want to have that plus or minus when you inflict that square root. So, we would get 12 plus or minus 4, and then you would actually do 12 plus 4 and 12 minus 4. For J, for this one, let's talk about how to get rid of the 2/3 power. A 2/3 power, basically the 2 represents a square and the 3 represents a cube root. Now, if you like, you could get rid of each individual power first. So let's kind of do it like that. It might be easier for you to kind of see what I did. So to get rid of the 3 in the bottom, let's cube both sides. Now I'm just going to write 49 cubed, okay? So now I'm going to get x plus 3 squared equals 49 cubed, okay? Just so that I don't necessarily have to completely rely on a calculator at this point. Now, if I want to do 49 times 49 times 49, you can. And then let's think about, at this point, it becomes exactly like C. We can get rid of the square by square rooting. And so this would be plus or minus the square root of 49 cubed. Now, what we can do here is you can just take the square root of 49, which is 7. And so then it just becomes 7 cubed, which is a little easier to do in your head than if you did it by yourself. And so we would get x plus 3 equals plus or minus 343. And then we would subtract 3, or negative 3 plus or minus 343. Now I tend to always take this number here, set it in front of the plus or minus, and change its sign. So you see it was a positive here, and now it became a negative there. And then you physically want to do that, but I figure you can do that much. Now, part I, the reason I say that it's kind of similar to the ones we just saw, we have this piece here that if we get it by itself, similarly as the C and the J problem, we'll be able to solve it. So let's think for a moment. If we took and moved the 5 to the other side, then we can get rid of that square root by squaring both sides. And so then we get 9 minus x equals 25. And then it's just a problem to solve. You subtract 9, negative x equals 16, so x equals negative 16. So pretty straightforward there. So those are very similar. Now I would like to take a look at the ones that are quadratics. So let's take a look at A, B, D, E. Yeah, let's take a look at those 4. Now those are all quadratics. They have 3 pieces in them. Usually a good strategy is to set them equal to 0 and factor. So if you want to solve those, like now A, I usually don't care too much for this negative right here. So I do tend to like to move it to the other side where it's going to become positive. And so I would probably do x squared minus 5x plus 6. Now, most of the time with these, the strategy you're trying to do here is to solve by factoring. And so this is a factorable quantity, x minus 3 and x minus 2. Now let's discuss why. The factors of 6 that add up to 5 are 3 and 2. Negative 3 times negative 2 is going to make that positive 6, but add up to negative 5. And so then your answers are x equals positive 3 and x equals positive 2. That's the strategy you want to take for all of those. For part B, because of this 1/9, you can multiply everything by 9 and get x squared minus 9x minus 162 equals 0. So that's just kind of a little trick you can use. So, and then that's factorable. D here, I would probably move both of these pieces to the other side. I would probably make that x squared plus 4x minus 8 equals 0. Now that's one that, so look what happened for this one. The x squared I pulled over here to make it positive, so the 4x stays positive, but the 8 becomes a negative. Now the factors of 8 are 4 and 2, which have a difference of 2, and 8 and 1, which have a difference of 7. But we have a 4 sitting here, and so this is one you would want to solve using the quadratic formula. And if the quadratic formula gave you positive square roots, those are your two answers. If it gives you a negative under that square root, you would say no real solutions. For E, move that 5 over. As you can see, that's not factorable either. And let me remind you of the quadratic formula. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this particular problem, your a value is 1, your b value is 4, and your c value is 5. And you just have to plug them into the formula using order of operations. Now, my suggestion would be to, really watch your order of operations. Maybe remind yourself that this line is under this entire thing. So you want to get an answer and then divide by 2a. So just watch that. Does anybody have any questions on the first problems I've done so far, or at least got started with? Okay, let's take a look at problem G and H. Now, let's start with H for a moment. Well, let's do F and H. For F, you are going to want to get that equal to 0. So I like my highest power to be positive. So I like that this is positive already. So I subtract it and put that there. Now that's just a factorable quantity. You want to factor, then you want to go from there. So if we would keep going, we can take out a 4 and an x. And then we're left with 9x squared minus 16, which is a factorable quantity, 3x minus 4 and 3x plus 4. And then you set each one equal to 0 and solve. Okay. Let's take a look at H. Now H is acting like a quadratic, but it's not a quadratic. See how this power is double this power, and then this one has no power? So it's kind of acting like a quadratic. My hint for that one would be, let's see here. I'm sorry, I'm kind of shoving these things in here. Would be to write it like this. What I notice here is this is going to be factorable because 4 from 7 is 3, so it will be factorable. Let me just factor it and then we'll move on. Remember, once it's factored, set each factor equal to 0 and solve each factor individually. And so if you factor it, that's what you get. And then you set each piece equal to 0. Let me do one of these as far as setting it equal to 0. If you get x to the 1/3 minus 1 equals 0, that's x to the 1/3 equals 1. And what's going to get rid of a 1/3 but a cube? And so x would be 1 cubed, which is just 1. The other one's a little harder, but. Okay, now let's talk about the fractional ones. And I know I'm going through this kind of quickly, but we got a lot to do, so I'll do my best to not talk too fast. For G and K, remember, those are ones with excluded values. So I know in the past, Alex has asked, what are the excluded values? For G, if you set each one of our denominators equal to 0, our excluded value is only 0. In K, if you set each of the bottom equal to 0, our excluded values are -2 and -4. So let's write those down. So for G, we know that we can't have a 0. And for K, we can't have a -2 or a -4. Now, those are just the excluded values. They just remind us that if we get those as answers, we can't just keep that as an answer. We're going to, get rid of it. For both J and K, or G and K, you are going to multiply through by the common denominator. So let me kind of get you started with that. So for G, multiply everything through by x squared, because that's your common denominator. For K, we actually need to multiply by two things, an x plus 2 and an x plus 4. Okay, now I've kind of started all of the problems you see here, A through K. Is there any one particular that you wanted me to keep going and do the final steps before we move on to number 2? Okay, let's take a look at number 2. Now, number 2 says to find all complex solutions. So that means that we will most likely have some i's involved. For A, I would multiply through by 2. If you multiply everything through by 2, you get 3x squared minus 12x plus 18 equals 0. Now, everything is divisible by 3. You could take out a 3. And then you can always jump to the quadratic formula for complex solutions. B is factorable. Let me think how. Let's see here. So the factors of 144, let's see. So we know that's 12 times 12. I think 9 goes in there. Let's see, 144. Well, 9 and 16, there it is. So this one factors to be x squared minus 9 and x squared plus 16. Now here's where the complex solutions come into play for number 2. Normally we think, oh yeah, this one's factorable, but this one is not. If you solve them each individually, this one gives you x squared equals 9. This one gives you x squared equals -16. And so this gives you plus or minus 3. This gives you plus or minus 4i. So that's where the complex solutions would come into play. And so make sure that if you get a square root of a negative, that you just evaluate it like normal and then throw an I on your answer. Part C, get that equal to 0. And then that is one that is done by grouping. So if it says, in this particular case, find all the complex solutions, for A, the highest power is a 2, so you should get 2 answers when you're done. Part B, the highest power is a 4, you should get 4 answers. And part C, the highest power is 3, you should get 3 answers when you're all done. Okay, so watch, if they say complex, use that power to guide you that you should get that many answers. Okay, any questions on number 2? Let's take a look at number 3. To solve inequalities, you're going to want to get them equal to 0 or relate them to 0 and then make a plus or minus chart. So let's go ahead and do that. Let's do, let's talk about A. A, you want to get it like that. You want to factor it. We're going to make the plus minus chart. Set each piece equal to 0. So I set x plus 2 equal to 0 and x minus 4 equal to 0. And then I'm going to put those numbers on a number line in least to greatest number line order. Now look back at our symbol. Our symbol is a greater than symbol. So put open circles. If it had the equality, we would put a closed circle. And then we're going to turn this into a chart. So remember, you're going to put the factors along the side here. And then you are going to get some test values along your number line. So let's go -3, 0, and 5, anything that is in that region. And you're going to plug those into here and just ask yourself, do I get a positive or a negative? Well, if you plug in -3, you get a negative. If you plug in -3 here, you get a negative. So a negative times a negative is a positive. If you plug in 0, you get a negative in the first one, positive in the second one, so there's a negative. If you plug in 5, you get a positive, which is positive. Now, it says, go back to your problem. Once it is in factored form, look at your inequality. It was a greater than, so we want the positives, which are those, so color those in. Now you're not done, and Alex will ask you for interval notation. And so our answer goes from -infinity just up to -2, and then from 4 to infinity. Okay, so that's the way you want to do all of those. A, B, and C, pretty straightforward. You're going to factor, make your plus minus chart. The one I want to work on now is part D. Any questions about A before I move on to D? Okay. Now D is already in factored form, so we're going to take each factor on top, solve it. So 9/5 is 1.8, and then the other one, if we solve it, we get 9. Okay. We're going to put those on the number line in least to greatest order. That does say 9/5. Now, the factor on the top, the 5x minus 9, gave us a 0 of 9/5. Because of that equal to right there, that one is going to be colored in. The bottom, no matter what, is undefined because there's actually an asymptote there if you looked at the graph. And so that one has an open circle. So bottoms always get an open circle. Tops are open or closed based upon what the problem said. So that said equality, and so we use the equality. So the 9/5 is colored in, the 9 is open. Now we're going to make a chart. Along the side, we write in the factors. We don't care if they come from top or bottom. You do the same thing. We're going to get some test values. Now remember, 9/5 is 1.8, so why not go 0? 9/5, 1.8. What's after that? Let's go 2 and then 10. Okay, so let's plug those in. If we plug in 0, we get -9, so that 2 negatives multiplied or divided is a positive. We plug in 2. Let's see, 10 minus 9 is +1. 2 minus 9 is a negative. And now let's plug in 10. We get 50 minus 9, which is positive. 10 minus 9, which is positive. So this middle is negative and this bottom back is positive. Go back to the problem. The problem says greater than 0, which means positive, and color in your positives. Write your answer as interval notation. So our final answer is -infinity to 9/5. Oh, that one gets a bracket. And then 9 gets a parenthesis and keeps going. Okay, so that is your final answer. Any questions about the inequalities? Okay, let's talk about lines. Write an equation of a line through the given point that is parallel to or perpendicular to the given line. Parallel, so here's the thing you need to remember. Parallel lines have the same slope. And then you also want to remember that perpendicular lines have opposite reciprocal slopes. Okay. Another thing for you to do this problem, number 4, you need to know the formula, the point slope formula, which is y minus y1 equals m times x minus x1. I think are the most important things to know for number 4. Okay. So I'm only going to do one of them. We'll talk about, let's start with number 4. The original line, 2x plus 3y equals 5. Let's do a little rewriting. Let's solve it for y. And so we get -2x plus 5 on the right side. And then if we divide off the 3, we get that. Now the only thing we care about is this number right here, that -2/3. So for the parallel, we're going to use a slope of -2/3. For the perpendicular, we're going to use the slope that is the opposite sign of that, so positive, and the flip of that. So instead of 2/3, we're going to use 3/2. Okay. Now we're still going to use that same point, -1/2, 5/3, in the formula that I wrote down right here. Y minus y1 equals m times x minus x1. And so the first one will be y minus 5/3 equals -2/3. X minus -1/2 will become plus 1/2. So that's your answer. Y minus 5/3 equals -2/3 quantity of x plus 1/2. Now, if Alex wants you to put it in slope-intercept form, distribute the -2/3 and then add 5/3 to the other side. For the perpendicular, instead of a -2/3 there, it's the exact same thing, but you're going to put a 3/2 in that spot right there. Okay. Let's just talk about 4 real quick before we move on to number 5. For number 4, you might notice there's only an x. Can anybody tell me, do you guys remember if there's only an x in the problem, what kind of line is it? If there's only an x, what kind of line is it? Yeah, it is. It's a vertical line. So if I am perpendicular to a vertical line, I'm a horizontal line. So I am a y equals line, and so a perpendicular line to B is y equals -7. If I am a line parallel to line B, I'm also an x equals line, and I'm x equals 5. So that one's kind of a tricky one. So perpendicular would be y equals -7. Parallel would be x equals 5, because they want you to recognize that this is a vertical line, okay? Okay, let's take a look at number 5. A pharmaceutical salesperson receives a monthly salary of $4,700 plus 3% commission of sales. Write a linear equation of the salesperson wages in terms of monthly sales. So it's just the wage is 0.03 sales plus 4,700. Now the reason we know it's linear is because both our x and y are just standard first power x or y, or w and s in this case. It's technically, you could think of that as y equals mx plus b. Our b is that 4,700. Our slope is that 0.03. Our x and y are the w and s. 6, that is just a function. I know almost all finals I've seen for 1510 is dealing with functions. So let's do 6 and 7 real quickly. Remember how a function works. So let's look at the g function they've given us. G of t is 5t squared minus 9t plus 3. That means whatever our input is, we're going to square it times 5 and then minus 9 times it plus 3, okay? So like if we start with 6, if we plug in 2, I'm not going to do the whole thing, but I'll set it up. That's going to be 5 times 2 squared minus 9 times 2 plus 3. Very straightforward. Watch your order of operations. You would square, then you would multiply, then you would multiply, and add and subtract. Now I want to talk about part B. Part B, g of t minus 2. Well, wherever the input is originally, take it out, and where you see the t, we're going to put t minus 2. And then you do have to be careful about your order of operations, okay? So like you want to square this by writing it out twice. You know, you want to write it as t minus 2 times t minus 2 before you multiply by 5. And then you need to distribute the -9 and so on. Any questions about number 6? Let's look at 6c real quickly. G of t is the function you see here. They want you to take the function you see there and minus off g of 2. Well, what have we found in part A? G of 2. It's going to be a number. You're just going to subtract those two things. So don't overthink these, okay? Let's look at 7. 7 is a piecewise function. It's very easy to get caught up in the fact there's 3 pieces and which piece do I use. So let's go through 7 for a moment. If our input is less than or equal to -2, so -2, -3, -4, -7.2, it goes here. If our input is some value between -2 and +2, we always get 0. If our input is bigger than 2, bigger than or equal to 2, so 2, 2.7, 9, 100, we do this function and only that function. So if we look at our first function, -3, which function do we input it into? The top, the middle, or the bottom if our x value is -3? Which part do we input it into? The top, the middle, or the bottom if our x is -3? Exactly. We would have to input it here because our x value is less than or equal to -2. And so this one, we only use this function. And so this is only 1 minus 3 times our input, which is 1 plus 9, or 10. Now, where do we plug in a 4? Top, middle, or bottom? This time, exactly, we have to use the bottom because our input is bigger than or equal to 2. And so our bottom function says that we square the input plus 2. And so this is going to be 4 squared, or 16 plus 2, which is 18. And then finally, the C, our input is -1. Is that our top, middle, or bottom that we use? Now it's the middle, exactly. And so our answer, without thinking, they have done the math for us. It's always 0. Let's talk about domain. The domain of a function depends upon a few things. If it is a polynomial like a, the domain is all real numbers. Nothing messes that up. You can put in positives, negatives, fractions, square roots, anything you want. Okay? If you looked at the graph, it would stretch from left to right. It has no vertical asymptotes. It has no starting, stopping points. It's perfect. B, it's a square root. Square root, the thing to remember is that your inside has to be greater than or equal to 0. And so we just think about, where is x minus 14 greater than or equal to 0? Well, in this case, that would be anything greater than or equal to 14. Now, if they wanted that in interval notation, that would mean that our domain starts at 14 and keeps going to infinity. Put that bracket there to say it's an equality. Okay. Now, C has everything wrong with it. 1, it's got a fraction. Fractions denominators are not allowed to equal 0, so that's an issue for that one. And it also has a square root. Now we know what the square root does from part B. The square root is that s minus 5, I'm sorry, I make my s's look so much like 5s, has to be greater than or equal to 0. We know that. So we know for sure that s's have to be greater than or equal to 5. Okay. Now let's look at the bottom. The bottom is a fraction that we always know the problem there is that the bottom cannot equal 0. And so we know that s minus 9 cannot equal 0. So we have to throw out 9. So if we look what happens, we are using all values that are bigger than or equal to 5 except for 9. So as we go, we would start at 5. We would keep going until we get to 9. There would be an asymptote there. We would leap across it, and then we could keep going. So those two things have to form what we call an intersection. Where do those two things both happen simultaneously? And so you have to account for both things. So the main thing to remember for domain, fractions bottoms cannot equal 0, so throw out any values where the bottom is 0. Square roots have to be greater than or equal to 0. Those are the main things to remember for domain. So we've looked at our first page here. Are there any problems on the first page that anybody has a question on before we move on to page 2? Okay, let's keep going. Page 2 is about graphing. Again, it is very easy to make these harder than they are. Let's take a look at 9. F of -3. So this is saying, technically, if x is -3, what is y? Now that's the very elementary way of thinking about it. So function f, and it just tells you I'm looking at the f picture. If x is -3, what is y? So if we go over here to -3, and we go down, it appears to me that y is -5. So I would say that the answer to this is -5. Let's look at f of 2. When x is 2, it appears as if my height is 0. Let's look at f of 0. When x is 0, it appears that my height is 4. And f of 3, when f is 3, it appears that my height is negative 5. Any questions on using that graph? Okay. 10. Determine whether graph represents y as a function of x. Does it pass the vertical line test? So that's a no. That's all that means. Check the graph. Does it pass the vertical line test? Increasing, decreasing, constant. Let's just go through this real fast. My function is going uphill until an x value of 0. My function is going downhill till an x value of 2. My function is going uphill for the rest of its life. Now let's assume those are arrows there. So how do you write that? Well, it's increasing from an x value of negative infinity to an x value of 0. It's decreasing from an x value of 0 to an x value of 2. And then it's increasing from an x value of 2 to an x value of infinity. Okay. Any questions there? Let's just look at B real quick. I'm not going to write out the intervals, but again, think about what you want. Increasing to an x value of 0. Constant from an x value of 0 to an x value of 2. And then increasing again from an x value of 2 probably to an x value of 4. And I would assume this x value here is probably negative 5. So there you go for that one. For increasing and decreasing, they will use parentheses because that endpoint where the two things join, which do you make it? So just use parentheses there. Okay, let's take a look at 12. We're going to just discuss the graphs real quickly, and if you have questions, let me know. So 12, this is a piecewise function. It's going to be a line till negative 5, and another line after negative 5. Okay, and so basically what you want to do is draw that line. It's going to look something like this. And then draw the next line that starts at negative 5. It looks something like this. Something like that. Okay. For B, you're going to have a parabola up to 5, and then you're going to have a swoosh square root at 5. We'll come back to that if we have more time. Let's take a look at just the standard graphs and the transformations. Okay, I just want to talk them over. So part A is a parabola. Now remember, if we add on the inside, we're going to go to the left. If we subtract on the inside, we're going to go to the right. So if we look at this one and this one, they have gone left and right. Okay, so we know this top one has gone to the left 8. And if you're unsure, just put what's on the inside equal to 0 and solve. And you can see that my x is now at negative 8, which is to the left. Now, a negative in front of the function is going to flip it. And then this is really a plus 3. And remember, if you add or subtract on the outside, it's going to move it up or down. So let's just kind of go down the list here. This is going to go up 3. This one's going to go up 5, down 5, up 4, because that is positive. Don't look behind it. Look in front of it. Down 2. Okay. Let's take a look at B. it's going to look like this. So we can even then say for number 1 that it's going to flip upside down. Part B, I'm sorry. It's going to be a cubic, left end down, right end up. It's going to go to the right 1 and up 5. Number C is going to be a V, but it's going to be flipped upside down. And it's going to go down 5. That's a step function. Normally the steps look like this. Sorry, my steps are so ugly. The negative in front is going to take our steps and make it a descending staircase instead of an upward staircase. Something like that. That's what this negative right here is going to do. And then the 4 is just going to lift the steps up 4 higher than they should have been. So just all of these steps go up 4. We didn't talk too much about step functions. Now, this is a weird one. This is going to flip our, usually a square root goes like that. But since there's a negative in front of our x, it goes like that instead. Okay. If you go 6 minus x equals 0, you get that 6 equals x, so it's gone to the right 6. And the minus 2 is going to bring it down 2. So it's just going to take this function, this point at 0, 0, and move it to the right 6 and down 2. So I would look over the rules of transformations, moving it left and right. Let me talk you through it one time. If you add on the inside, you're going left. Subtract on the inside, go right. Add on the inside, go up. Subtract, or I'm sorry, add on the outside, go up. Subtract on the outside, go down. If there's a negative on the outside of the function, it's going to flip it upside down. Those are the main ones to remember. Okay, these ones. We really only have to do 14. We can kind of skip 15. Maybe the domain we could talk about, but let's take a look at 15. To add the functions, don't make it harder than it is. Just list them up and add up like terms. So this is just x squared plus 3x minus 5. Now be careful when you subtract functions. The second piece, always put in parentheses, like whatever you're subtracting, put in parentheses so you remember to distribute that. So that's my main key to remember. If you're subtracting functions, always put the second function in a parenthesis. For multiplying functions, put both functions in parentheses. That hopefully will remind you to distribute. And to divide functions, put them, you could probably put them in parentheses as well. Now, for the domain of f divided by g, remember, it's a fraction. What's going to screw up a fraction? A 0 in your denominator. So 3x minus 5 better not equal 0, and that's going to help you determine your domain. So that's the main thing for functions. Let's take a look real quick. Yeah, I think that's good for that. Let's take a look at composition. I want to go both ways. So I want to look at 16a and b. 16a. Now remember, that means take our f function and plug g of x into it. Okay, so we're going to put x minus 5 into the f function. So inside your f function, write x minus 5. So we're going to have x minus 5 squared. Now the other way, g of f, we're going to take the g function and put f of x inside of it. So it's the opposite direction. So we're going to take the g function, and this time we're going to plug x squared in. So that's going to go right here. And so that's going to be x squared minus 5. You get two very distinctly different answers for the most part. For most functions you do. Okay. I think 16, 17, 18, they're all kind of, if you know what 16's doing, you'll be good. Okay. Let's take a look at using functions to evaluate things like this, you know, an actual picture. F plus g of 1. That is really just f of 1 plus g of 1. Now remember when we used the functions earlier? We used the pictures. So go to your function, f of 1. What is the height at 1? Well, it's 2. And then if we go to the other function, what is the height at 1? It's 3. So the answer is 5. Now, I want to do a function like 19c. Okay. F of g of 2. Now, we're going to start on the graph of g. We're going to start with the innermost function. We're going to do this. What is the height of our g function when x is 2? So here, let me make that green. So if we go over to the g function, which is the rightmost function, and we look at the height at 2, the answer is 2. Now we're going to go to the f function, which is this one, and we're going to say, okay, when x is 2, what is the height on the f function? And our answer is 0. Okay, so let me go over that one more time. We're going to take 2 and use the g function. That's 2. Then we're going to take that answer and look at the f function. The height is 0. Now part D, you start with the f function, then go to the g function. So you have to go in the inside and work your way outward. Any questions about 19? Okay, let's take a look at 20. It says use the graph of the function to sketch its inverse. So what I like to do, I'm going to do the same thing I've always done with inverses. I know those are a little bit fuzzy, but I'm going to take and I'm going to kind of plot out some points. So that looks like the point 0, 2. This one's a decent point. That looks like the point maybe 1, 3. Let's get one more point, maybe this end point here. That looks maybe like it's 5, 4. Now in inverse, remember, its job is to flip the x's and y's. So if you flip-flop the x's and y's, I'm going to list them over on the side. I'm going to get 2, 0, 3, 1, and 4, 5. So now let's graph them. 2, 0, 3, 1, 4, 5. And graph them. And so it looks like it should have flipped over the line y equals x. So there you go. So there is number 20. Any questions about that? Okay. 21. Does the function defined by the graph have an inverse? A graph has an inverse if it passes both the vertical and horizontal line tests. This one does not. That one is a no. It doesn't pass the horizontal line test. If we just graphed this much of it, like just maybe that quarter circle, it would be a yes. But since that whole circle has those repeating horizontal values, it's a no. Determine whether the following function has an inverse. 22 is a yes. Because it's a line, it's going to be fine. 22a is yes, it's going to be a line. 22b. Now, this is a parabola that's moved to the left one. Do you see here where it says I only want the x's greater than or equal to 1? Negative 1, I'm sorry. That means I'm only using half of the parabola. So does it have an inverse? Sure does. Now let's practice finding those inverses, okay? So let's do both A and B. We'll practice those. So let's start with A. For part A, we're going to write it in Y notation. We're going to flip-flop the x's and y's. And then we're going to solve for this y right there. Okay, that's going to end up being our inverse. So subtract 9, divide by 8. So our inverse is x minus 9 over 8. Okay, now let's do the same thing with 22b. Okay, I'm going to write it in Y notation so then I can make it a little bigger. Sorry, I'm writing so little here. So I'm going to write it in Y notation. I'm going to flip-flop the x's and y's. Now, to get rid of a squared, I square root it. Now, you know how we have that plus or minus? This restriction means we only use the positive portion of the graph. And so we end up like this. We end up getting the square root of x equals y plus 1. So y equals the square root of x minus 1. Did they use f? Yep. And so our inverse is the square root of x minus 1. Any questions on finding inverses? So I definitely want to practice getting a parabola into standard form, finding the vertex, the x-intercepts, y-intercepts. So let's do 23. Okay. So you don't want to get it into standard form until you find the vertex. Do that first. So the first thing you can find very quickly is the negative b over 2a. Now that's actually our axis of symmetry. So we're doing lots of things all at once. And so our a value is negative 1. Our b value is negative 4. Now let's plug those in. And so we get 4 over negative 2, or negative 2. That's our axis of symmetry. Now you want to write an axis of symmetry as x equals negative 2 for a parabola that's up and down like this one. Well, it's upside down technically, but... Now, what else do we need to know? Well, a vertex is a point, not just the x value. If you have an x value, you can find the y value very easy. Just plug it in. And so, if we plug in negative 2, what do we get? Well, we get the opposite of negative 2 squared minus 4 times negative 2 plus 1. Which is the opposite of 4, plus 8 plus 1, which is 9 minus 4, or 5. So what we know now is that our vertex is negative 2, 5. But what we know, technically, is that's our HK. So we know A, we found that earlier, that's negative 1. We know our h is negative 2 and our k is 5. So we know standard form. So we know negative 1, and you can write that as a negative symbol or the number negative 1, whatever floats your boat. And that's going to be x plus 2 squared plus our 5. Now let's analyze that for a minute. Our h changes sign. Because this is h, this says the opposite of h. So this one in the parentheses changes sign. The one outside the parentheses does not. Okay, so you really find the vertex, which gives you the axis of symmetry, which gives you the standard form, all at once. So it's really, really a nice procedure. I tend to always do that together before I go on. Any questions on that first section of things? Okay, now let's talk about x x-intercepts. X-intercepts are where the function equals 0. Use your standard form. It's where the y equals 0. Let's switch colors so you can see that. It's where the function equals 0. Now you can do either where 0 equals negative x squared minus 4x plus 1 equals 0, but then you're going to have to factor it. This one is already ready to go. If you set that equal to 0, watch how easy it's going to be to solve it. Oh, I'm sorry, that's so yucky. Move the 5. Divide off the negative. Take the square root. You got to have that plus or minus. Move the 2. Put it in front, make it a negative, and put it in front of the plus or minus symbol. Okay, and so I tend to, if I've gone through the trouble to find the standard form, I think it's easier to solve for the zeros than any other way, unless it's a very simple thing that factors easily, but they're not usually like that. Okay, so now we have everything. We've got the vertex, axis of symmetry, the standard form, and the x-intercepts. Now let's go to the y-intercepts. The y-intercepts are the easiest one. You just plug in 0. And so if we plug in 0, we get 0 minus 0 plus 1. In the quadratic formula, remember how we've got that a, b, and c? It's always going to be the c value. So the y-intercept's always the c value. It's always that constant. Any questions about your parabola stuff? Okay, wait, let's look at what we got here. I know there's so much, I'm sorry. I'm doing the best I can. There's a lot to go through. I want to do 25, just part A. It says, write the standard form of a parabola with the indicated vertex and point. So we know the h and k. So that's what this is right here. So we know that our h, k, is 6, negative 1. So let's put that in, okay? So we get y equals a, let's see, times x minus 6 squared minus 1. Do you see how the 6 changed signs? Because it's in the parentheses, but the 1 does not, because it's outside the parentheses. Okay, so all I did was put that in. Now you'll notice that the thing we don't know is the a value. But this is going to help us. So what we're going to do now is we're going to plug in, this is our x and this is our y. And we're going to put those here and here where x and y is. And then our only variable will be the a. Okay, so let's put an x value of 4 and a y value of 7. Oh, 4 minus 6 is negative 2. That's in the parentheses. When you square negative 2, you're going to get 4. Add 1 to both sides. So a is 2. So now, as soon as you have a, you know h and k, revisit this, and stick the a where it belongs, right here. And you got it. So the equation is y equals 2 times x minus 6 squared minus 1. And that is your answer. Any questions about 25? Okay, let's look at 26. 26 says, to sketch the graph using the lead coefficient test, find the zeros, plot sufficient points, draw a continuous curve through the points. Okay, so let's do this. Let's do I want to do A? Well, let's do let's do A and C. So if we look at A, the lead term is x to the 4th. So it is going to go upward like a parabola. Let's just look at the lead terms of these for a minute. For part B, the lead term is negative 4x cubed, which means it's going to look like a cubic that has been flipped upside down. It's going to have bumps in it, but ends are going to look like a cubic. And then finally, the lead term here is kind of hidden. It's like negative 1/4 times x squared and times x squared. So its lead term is a flipped upside down x to the 4th. So that's kind of how you judge the lead terms. Okay. Now let's go back to A and let's decide how we're going to draw it. So we want to try to factor it if possible. And there is an x squared living in both of those. And then we can factor one more time. So what does that tell us? Well, we have zeros at x equals 0. Do you see how there's two of them? So that means that there is a bounce. And then we have an x equals 3. We only have one of those. And an x equals negative 3. So at 0, we're going to bounce. At 3 and negative 3, we're going to slice through the x-axis. So put them on the x-axis in number line order. First, just plot those out. We know the left end's going to go up, the right end's going to go up. We know we're going to slice through negative 3. We're going to come up and bounce at 0, and then we're going to slice through positive 3. So that is what our graph looks like for 26A. Now let's go to 26C. Now what's really great about 26C is they have done the factoring for us. And so because of that, we have a 0 when x equals 2 from this one. See that squared there? There's going to be a bounce. And then we have a squared here. There's going to be also a bounce at negative 2. And so if we draw this one, using kind of the same idea, at negative 2 and positive 2, there are going to be zeros. We know that the ends are going to be pointing downward. We know it's going to bounce off of there and bounce off of there. And so it looks something like that. Okay. Any questions about 26? Okay. Let's do one long division. Let's do 27A. Let me write it over here and then I'll make it a little bigger for you. So remember when we do long division, check your powers. They should be in descending order. Our power here goes 3, 2, 1, and nothing. So I can just write it down. And I'll make it bigger for you, I promise. I just got to write it down first. Okay. So we are going to compare our first term with our first term. What times 5x would be 10x cubed? That's going to be 2x squared. So put it over the x squared to kind of keep track of things. You can see where you need to stop and where you can keep going. Now remember, we're going to distribute that to both of these. So that's going to be 10x cubed minus 8x squared. We are subtracting, so we're going to change the signs of both. So the first term should always go away. That's the way you've designed it. If it didn't go away, you did something weird. So then we got minus 20x squared. Bring down the next one. Do it again. What times 5x is negative 20x squared? That's going to be negative 4x. We're going to distribute to both. We are subtracting, so change the signs of both. The first term goes away. 41 plus 16 is 57. I think my signs are a little weird here. Wait, let me go back. Thank you. I just thought, I think my signs are messed up. Okay, so negative times a negative would be a positive 16. And then I am subtracting, so that would be a negative. Thank you very much. And then we've got, what, 25? That looks better. Bring down the next one. We're going to multiply by 5. We are subtracting, so we change the signs of both. And there is our remainder. Okay, so there's a long division problem. Although they didn't ask, do they ask synthetic division somewhere? I don't know. Let's just do a synthetic division to 27b real quick. So it's a candidate because we've got that x minus 3. So you're going to put 3 in the corner. Do you see how our powers here are 3, but then there's no 2 and there's no 1? So we're going to put our coefficient of 1, then the squared, then the x, and then the 27. So I'm going to do synthetic for 27b. Okay? So it was x cubed minus 27 divided by x minus 3. Okay, so I'm just setting up the box. So we were missing the squared and the x, so that's why there's zeros there. So I use the coefficient 1 and negative 27. So we're going to multiply, write it down, add them up, multiply, write it down, add them up, multiply, write it down, add them up. Now we got to put our x's back on. This was a cube, so this becomes a squared. And that's it. So that is that. Any questions on division? Okay, let's jump to 29a. It says 29a, find all real solutions to the polynomial equation. I need some room for this one, so let me copy it and paste it to a new page here for a minute. Now, this is like saying what are all the real zeros of f of x equals z to the fourth plus z cubed plus z squared plus 3z minus 6. Okay. Now, remember, this back number can help guide us find the real zeros. And so that's our p's over q's. Remember that idea we had explored when finding zeros. You just want to look at what are numbers that go into 6. So I would say plus or minus 6, 3, 2, and 1 are going to be my starting point. I'm going to use this as my polynomial. And I'm going to just start plugging those numbers in. Now, I usually start at 1. You know, here we got 1 plus 1 plus 1 plus 3 minus 6. Hey, that's 0. So I automatically know that z minus 1 goes into there perfectly. And so that's where let's take it out. And so if we take out 1, I'm going to do synthetic division. And I'm going to just go do the synthetic division to take that z minus 1 factor out. And so you multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down, add them up. And we get 0. Now here you'll notice, well, these are z's, not x's. Let's call this our polynomial, let's call it f of z. So this was a fourth, so now we're down to cubes. Sorry, I always want to write x's. And then, you know, anytime I see a cube, I always look for patterns. I do like the fact that these two have coefficients that are doubled, and then these two have coefficients that are doubled. I think I can use, I'm sorry, what's it called? Grouping. So I'm going to group these two together and these two together, and let's hope for the best. If I group the first two together, I can take out a z squared. If I take the second two and group them together, I can take out a 3. And look what I get. I get a z plus 2 hanging out there in both of them. So what do I know? Well, the real solutions, so this factored to be z minus 1, z plus 2, z squared plus 3 equals 0. Now that's the factorization. The solutions, the real solutions, are hanging out just in those two things, when z equals positive 1 and z equals negative 2. Now if they said to find all solutions or complex solutions, you can't forget about this dude here. Z squared plus 3 equals 0 when z squared equals negative 3, or z equals plus or minus the square root of a negative. Now that's why it's not a real solution, it's a complex solution. And so that's plus or minus the square root of 3i. So watch how they write the answer. If they said to a problem like this, find all solutions, keep going and use your i's, your square root of the negatives. If they say to find real solutions, this piece you don't have to keep going. You know, you might want to do this to verify there's an I there. But that's basically as far as you would have to go. Any questions about that one? There's just so much, I know. Okay. Oh, let me find a good one to do with you. I want to see like some that has like, remember all the stuff that could go wrong, you know, the asymptotes and all that stuff. So what I would like to do with you is 33. We're going to kind of go down that entire list that that we have done in the past. So let's do 33. I think it kind of encompasses everything that you need to do a problem like 33. So let's take a look. The first thing you always want to do is to get it into factored form. So what I noticed here is that the bottom isn't factored, because the bottom can be factored to be x plus 4 and x minus 3. 4 times 3 is the 12. 4 minus 3 is the positive 1 in the middle. Okay, so that's factored form. What I notice is that we have a piece on top and a piece on bottom that matches. So I'm going to write the reduced form over here. And the next thing I'm going to do is what the whole is where x plus 4 equals 0, or at negative 4. Okay, so there's a whole at x equals negative 4. Now I'm going to kind of forget about that and deal with that at the very, very end. Okay, next thing you want to do are the vertical asymptotes. The vertical asymptote is what remaining factors in the bottom where those equal 0. And so that's where x minus 3 equals 0, or at 3. So the next thing I would do is finally our domain. So now we're ready to look at 1. I've done part of 3, but I always do them in this order no matter what they ask me, because it's the most efficient order and it really kind of keeps you organized. So what's our domain? we have to take out negative 4, we have to take out positive 3. So think about that number line order. Our domain is going to go from negative infinity up to that negative 4 hole. It's going to jump over the hole till it gets to the asymptote. It's going to jump over that asymptote, and then it's going to keep on going. So it's going to have 3 distinct pieces of the graph. A piece before the hole, a piece between the hole and the asymptote, and a piece from the asymptote over. Okay? So if you see your domain has been broken into 3 pieces, expect that your graph should be broken into 3 pieces. Any questions so far where we're at? Okay, so next thing I would do, let's go with our horizontal asymptote. Horizontal asymptote is a comparison of the power on the top with the power on the bottom. The original has a higher x power in the bottom. The simplified version has a higher x power in the bottom. And that is always a horizontal asymptote at 0. Now let me go over the rules real quickly. If the higher power is in the top and is 1 more than the bottom, there is a slant asymptote. If the higher power is in the bottom, it's always y equals 0. If the higher power on top and bottom match, then it's always the lead term coefficients will be your horizontal asymptote. Okay, let's do intercepts next. The x-intercept is where the top equals 0. The y-intercept, you just plug in 0. Okay, so those are the things to remember. The top of this is 3. 3 does not equal 0. So there are no x-intercepts. Now remember that. When we go to graph this, there are no x-intercepts. This graph never hits the x-axis. That's very important. The y-intercept, if you plug in 0 to the reduced version or the original, it doesn't matter. You'll get the same thing. You get 3 over negative 3 or negative 1. So I know I hit the x or the y-axis at negative 1. Now it says we've done the domain, we've done the intercepts, we've done the vertical and horizontal asymptotes. The last thing says to plot additional points as needed to sketch the graph. So we'll get to that. So let me find some graph paper here. Okay, so we've got some graph paper. So the first thing I put on personally is my vertical asymptotes. I have a vertical asymptote at 3. Next thing I put on is my horizontal asymptote at 0. Now, if I have 2 vertical asymptotes, I do tend to put my horizontal asymptote on the outside of those, but since we only have 1 vertical asymptote, just put it along the line, you should be good. Now, let's plot next our intercepts. We don't touch the x-axis, so keep that in mind. We never touch that, never touch that, never touch that. We do touch the y-axis at negative 1. We need some more points. Now, we have a hole at negative 4. So take our reduced version and plug in negative 4. Now remember, that's a hole. So if I plug negative 4 into here, I get 3 over negative 7. So that's not quite a half. It's like 0.4, negative 0.4. So at negative 4, go over to negative 4, and at negative 0.4, put an open circle. Okay? Now we need some more points, so let's deal with this region of the graph. Let's plug in I don't know, let's plug in 2. Well, let's get close to this asymptote. Now we know we never go through that line, so that's helpful to us. But let's plug in, let's plug in 2. So now I'm plugging into this. 3 over 2 minus 3 is 3 over -1 or -3. So over here at 2, I'm at -3. So it kind of does what I expect. It's kind of heading to this asymptote, heading to this asymptote. Now, I don't know much about what's going over here, okay? So I suspect it's right there. But it could be there. So let's get at least 1 or 2 points that's hanging out over here. And so this is at 3. So let's plug in 4. Let's plug in 4 and 6. Why not? Again, they're totally your choices. If you plug in 4, you get 3 over 1 or 3. If you plug in 6, you get 3 over 3 or 1. Now let's plot those. So at 4, we are at 3. At 6, we are at 1. So it is a little piece like this. Okay? So there is about everything we need for number 33. Any questions about graphing that rational function? Okay, let me go back and see what we're at here. Rational functions. Okay, so let's talk about circles. 35 says let's take the equation of the circle and put it in standard form. So I'm going to do 35a with you. So here's where, unfortunately, we have to complete the square. Now, the way that I do this is I write the x's together, which are these two, and then I put a blank. Then I write the y's together, and then I put a blank. And then I'm going to take any number that I see. The only number I see is 36. I'm always going to take it to the other side, change its sign, and put a blank for the x's and a blank for the y's. Okay. Now, I'm just kind of getting it ready. These, I'm going to complete the square to make this. Now, it's always going to be x minus half of that. So I already know it's going to be x minus 1 and half of that. It's always going to be that. Okay, so let's say that again. Whatever is on the x, this is always going to be half of that. So half of -2 is -1. Half of +12 is +6. Look how much I already have. Okay, but now the part that you have to worry about is finding the correct radius. So what do? Well, if I were to write this twice and square it, -1 times -1 would hang off the end, or -1 squared would have to go right there. -1 squared is 1. That's what fills my spot. For the y's, what's going to go right here? Well, it's always going to have to be 6 squared, because it's going to be y plus 6 times y plus 6. 6 squared is 36. That's going to fill my spot. And then you just add these together. -36 plus 1 plus +36 is 1. So what do we know? Well, the center is +1, -6. Remember, it's always the HK, the opposite of what you see here. The radius is the square root of the number hanging off the end right here. And the square root of 1 is 1. So there is 35, completing the square to find the standard form of a circle. Now you use that same technique if you're trying to put it into standard form for an ellipse. Even parabolas, you can use somewhat that same trick. Let's do the graph for 36. Just a second there, let me get a sheet of paper. Okay, it says sketch the graph of a function showing the horizontal asymptote. The standard, if it was like that, okay, that function will either look like that with a horizontal asymptote at 0, or it could be descending. If that b is like a fraction, sometimes it's going downhill, but it will always have a horizontal asymptote at 0. Now what changes the horizontal asymptote is any number that you see hanging on the back of there. That plus 7 is going to, remember, think about what it does. Its job is to move a function up or down, and so it moves it up 7. So I know, without plotting any points, that this graph is either going like this or is going like that. And so now all you have to do is plug in -1, 0, and +1. Let's see what happens. If I plug in -1, I get 2 to the -1 plus 7, which is 1/2, because that negative power flips it, plus 7, which is 7.5. So over here at -1, I am at 7.5. If I plug in 0, I get 2 to the 0 plus 7, which is 8, because 2 to the 0 is 1, 1 plus 7 is 8. I'm right there. And then if I plug in 1, I get 2 to the first plus 7, which is 9. And so my graph looks like that. Any questions about 36? Okay, I know this is so fun. Hey, I've been going pretty fast here, but I hope this is helping you remember all this stuff. Just 2 more pages, we're almost done. Okay, let's talk about logarithmic and exponential equations. Let's start with logarithmic. Let's do 37 and 38. 37. Remember, this is our base, this is our number, this is our power. So our number is our base to that particular power. And so this is very simple to flip. We know the number 16 better equal 4 to a power of 2. So once you identify, hey, what's your base? The answer to a logarithm is the power, so the number has to be the thing inside. You got it. So now let's flip it and go the opposite way for 38. Here's our base, here's our power, here's our number. So I know that the power 3 is the log base 2 of the number 8. So you should know how to go back and forth between those two things. Now, using that same idea, let's evaluate some of these logarithms. 39, what power could I put on a 64 to get the number 4? Well, 64 is 4 cubed, so the power has to be a cube root. So if you know anything about cube roots, the power has to be a 1/3. That's a tricky one. Part B, what power do I put on an 8 to get 1? The only power that's going to do that is 0. Part C, what power would I put on a 4 to flip it and make it a 16? Now, flipping it's going to be negative. Making it a 16 means I have to square it. So the answer here is -2. and D. Let's talk about how we could use our rules of logarithms to help us. Rules of logarithms say if the logarithmic bases match and we're trying to add the exponents, the logarithms, we can multiply the two things that are inside. So remember, addition becomes multiplication when we condense it. Subtraction becomes division. And so this really becomes the log base 6 of 36, which totally makes things nicer because now that's just saying, what power do I put on a 6 to get 36? So the answer is 2. Let's take a look at 40. What does the graph of the logarithm look like? The graph of a logarithm, you have to be very, very careful about what you plug in. Normally, like the exponentials, you plug in +1, -1, and 0, you got it, you're good. These ones, it's very hard to pick the correct thing to plug in. Now, let's talk about 40, and let's sketch the graph and do all that stuff. So I'm going to do 40A. .40a says to find the domain, the x-intercept, the vertical asymptotes. Now, the horizontal asymptote of an exponential was determined by the number hanging out on the outside. For a logarithmic function, you have a vertical asymptote, which is determined by what's on the inside. So the vertical asymptote for this is where x minus 4 equals 0, or a 4. So without doing much else, I know that the graph either is over here or over here. Now, if the x is a positive number, it's got to be over here somewhere. Now, it could be going downhill or uphill, but it's over here. Okay? Now, what do we pick? Well, normally, for a base 4 logarithm, I always pick 4 to the -1, 4 to the 0, and 4 to the first. Kind of the exact opposite of what I would pick for a, normally I pick the power of -1, 0, and 1. Well, here I pick a 4 to a -1, a 4 to a 0, and 4 to a 1. But we've got that x minus 4 in there. So unfortunately for this one, we have to pick where x minus 4 equals 1/4, where x minus 4 equals 1, and when x minus 4 equals 4. You have to pick very specific x's for them to work. So I need to know, where's that inside going to give me that? Where's that inside going to give me that? Where's that inside going to give me that? Very specific. If it was 5 base, I would pick 5 to the -1, 5 to the 0, and 5 to the 1. If it's a natural log, I'm going to pick e to the -1, e to the 0, and e to the 1. So I'm going to be very specific. For all of these, you can notice to add 4 is how you solve them. And so this is going to be 4 1/4. This is going to be 5, and this is going to be 8. So the x's I have to pick for this one are 4 1/4, 5, and 8. What am I going to get? Well, I'm going to get these really nice values, -1, 0, and 1. See how they're the flip of what you would get otherwise. In our exponential function, the x's and y's are reversed of what you see on this chart. And that happens for a reason. So now we can plug those in. Okay, so at 4 1/4, I'm at -1. At 5, I'm at 0, and at 8, I'm at 1. And that's it. They're kind of strange functions, but think about it is an exponential function lying on its side. You know, if I could turn that page over, it would look like an exponential. So there you go. There's a graph of a logarithmic function. So remember, an exponential function has a horizontal asymptote, where a logarithmic function has a vertical asymptote. Let's talk about condensing and expanding. Okay, so let's do B for 41. Anything on top becomes an addition for each factor. You'll notice that I wrote square roots as 1/2 power. That's a common thing. Any factors on the bottom become a negative, and then the last thing to do to expand is to drop your powers down in front. I'm sorry, I wrote that as a 1/3. Square roots are 1/2. So drop that 1/2 down in front, drop that 3 down in front, drop that 4 down in front. Okay? Now, for 42, we're going to go the opposite direction. We're going to put the powers back on. Any pluses are going to become multiplication. Any minuses are going to become division. So let's do 42b. First thing you want to do is put the powers back on. That's a plus, so we can put it back together by multiplying. So that's just going to be 64 times z minus 4 to the 9th. And that you want to somehow either use two sets of parentheses to make it clear that all of that stuff is inside of that one logarithm. Okay, let's take a look at 43. Now I want to do one that's set up nicely and one that isn't. We're just going to kind of go down the list and I'll get these started for you. For 43a, the nice part is that we could rewrite 27 as a power of 3. Anytime you can get these bases to match, that's really the key, because then you can cross them out. We're going over everything we possibly can today, so I'm going to try to go over everything you see here. And so, you know, if you can stay the whole time, stay. If not, I will post the video of me talking to myself. And once we get rid of these 3's, we can just set them equal and solve. We subtract 1 from both sides, and we get 2. Now, the problem with number part B is you can't do that. So anytime you can't do that, get the exponential thing by itself. In this case, stick a natural log in front. And then we get, because those cancel, we get that x is the natural log of 71 over 5. Let's do C. I don't know if I have enough room here, but let's try. Well, let me write it down here. Sorry, it doesn't want to cooperate. It's too tiny. There we go. Okay. Now, there's no way to make 7 and 0.9 be bases to match. Like if I saw a 49 over there, I might think, oh, maybe I can do something with it. Since you can't, stick a natural log in front. and I usually tend to go with the natural log, but it can be any logarithm. I'm going to drop this power down in front. Now the natural log of 7, as well as the natural log of 0.90, they're just numbers. So let's divide both sides by -8, natural log of 7, and then we got it. So t is just the natural log of 0.90 divided by -8 natural log of 7. If you were to enter that into a calculator, because I think it did say in the instructions, like to the nearest whatever, I would probably make sure that you put the whole top in parentheses and the whole bottom in parentheses. Just be careful when you enter anything into a calculator. So there's that. I want to do E. So here, get the natural log or any kind of log by itself and put it into exponential form. We know the natural log basically has a little e right there. So the number x is the base e to a power of 4. So you can definitely solve that by using exponential notation. Let's do 44. It says find the number of years it takes for $1,000 to double if it is invested at an interest rate of 1.4%, compounded continuously. If something says compounded continuously, you're going to use the PERT formula. So remember, continuously, PERT go together. And so our A, let me write it up here and then I'll make it bigger, is going to be our final value we want to be 2,000. Our starting value is going to be 1,000. Our rate, take that 1.4% and make it a decimal. And we want to know the time. Okay, so that's everything we need. Let's go ahead and take a look. So we get 2,000 equals 1,000 e to the 0.014t. Now, anytime you want to try to solve an exponential, get the e part or the base part by itself. So divide by 1,000. Anytime they say double or triple, they say double, you're always going to get this equal to 2. If they say triple, it's always going to end up being equal to 3. And then what's going to get rid of an e? But a natural log. So let's stick a natural log on, which is great because that's going to cancel. So we get the natural log of 2 is 0.014t. So t is going to be the natural log of 2 divided by 0.014. Now I've seen it say on Alex, what is your exact answer? So you would put in the natural log of 2 divided by 0.014. Now, if they say round to the nearest thousandth, that would be 49.511 years. I do not know about the formulas on this. In the past, when it was a paper pencil test, they had a sheet of formulas. I will ask. I do not know if in the Alex question itself, if they will tell you what formula to use. But I will look into that and I'll get back to you because I don't really, I don't know. Okay, so that's a good one for 44. Let's do solving a system. To solve a system by graphing like 47, you would just draw the lines. The solution is where do they intersect. But I want to use substitution. I want to do 48. Let's do 48a. So it says to solve by substitution, but you can really use any sort of method you want. I'm going to take this equation and rearrange it so I know that y equals 4 minus 2x. so that I can substitute that into here because I've got that very simple y, so that it doesn't say y's anymore, that it says x's. So let's go ahead and put that right in that spot. And so we get x cubed minus 4 plus 4 minus 2x. That's just where the y was sitting. I put 4 minus 2x equals 0. I get x cubed minus 2x equals 0. Now remember, we're looking for points that they have in common. So you want to find points. To solve it, first get the x's and then plug it back in to find the y's. And so solve this by factoring. So we have 3 points here, 0, positive square root of 2, and negative square root of 2. And now let's just find the y's that go with it. Now these are the y, this is the y formula, so just plop it right into that. So the y here would be 4 minus 0, or 4. So they are going to want points. And then here, the first y, if I plug in positive square root of 2, is going to be 4 minus 2 square root of 2. So that would be the point 2, 4 minus 2 square root of 2. And then if I plug in negative square root of 2, I get 4 plus 2 square root of 2. Wait a second here, that's better. So we get 3 points of intersection for number 48. Okay, so that is 48 for you. We're on to the last page. 49, I don't think I need to necessarily do that one for you. For 51, I would like to do 51A. If this was a paper and pencil test, I've seen them do a problem like 51, usually like one problem on the whole test. I've never seen this in ALEKS, but I have no idea what they're choosing for you on the ALEKS test. So I'm just going to do 51A, and then if there are any other ones that you have questions on, I can take a few more questions before we say goodbye. Okay, let's do 51A. I like 51A. It's a very good problem for something that occurs in calculus. So it is there for a reason. It's an expression that you would see in calculus. There is something in calculus called the derivative, and this appears sometimes when we do something called the quotient rule in the derivative. I don't know, but it's a formula. And they're just trying to get you a sense of kind of some of the algebraic types of things that you might have to simplify in a calculus class. So let's take a look at what you see. In this fraction, this first piece here is one term, and this back piece is one term. Do you notice anything in each term that you see in both? Do you notice anything in the yellow that you also see in the green? Anybody notice anything in the yellow that's also in the green? Yeah, that's 7x plus 1. Now the lowest we ever see it is right here. There's 2 of them. So technically what we can do is we can remove 2 of them. Now on the bottom, you notice here we've got 3 of them, and 2 of them we technically have 6 of them. So I'm going to write it as 6 of them. Okay. Now, let's think about what's going to happen here. Now, let's just focus on the yellow. In the yellow, I've removed 2 of the 7x plus 1s. So I have 1 of them remaining, and then I still have that 48x squared plus 5 remaining. Okay, now let's focus in the back. In the back, I took out the 2 7x plus 1s. So I still have an 8x cubed plus 5x. I have a 6 and a 7. Let's mush that together and make it the number 42. Okay? Now, we've accomplished something really nice. It doesn't look like it, but we have. We have 2 of these, and we have 6 of these. So we can cancel out 2 from each. So how many would we have left down in the bottom? How many of those 7x plus 1s would we have left? If we cancel 2 from the top and from the bottom. We'd have 4 of them left, right? Because I've taken out 2 from the top, so both of those are gone. If I take out 2 from here, I have to have 4 left. Now, since I've canceled those 2 out, then all I have left is what it's here. And so let's actually FOIL and make this a lot nicer than it was. So when we FOIL, distribute, whatever, we're going to take the 7x and distribute it. So 7x times 48x squared is 336x cubed. And then 7x times 5 is 35x. And then I'm going to distribute the 1, so that's going to be 48x squared plus 5. Now, all I did was distribute the 7x and the positive 1. Now here I'm going to distribute a negative 42 in one swoop, because negative 42 is what's sitting in front of or outside of that. So negative 42 times 8 is going to be negative 336 x cubed. And then negative 42 times 5 is negative 210. And something neat kind of happened. You might notice these two are exact opposites. So then if we go in order, we get 48x squared minus 210x plus 35x plus 5. There's not really anything else you can do with that. I mean, sometimes I would look to see, is this, factorable? It's not. It doesn't really follow your grouping quite right, because this would have to go positive, negative for grouping to kind of work. So that's it. So just kind of a weird one. Okay, so we quickly went over a little bit of everything, as you can tell. So we really kind of did a little bit of this and a little bit of that. Were there any other problems on here that you want to touch upon before we say goodbye? Yes, it was. That was like the whole course in 2 hours. No problem. Okay, so remember, I have posted the video that we did last week for the tests. I have no idea what this Alex test is like. I'm going to try to go in and see if I can gather any information, but I don't even know if I can see it or if I know anything about it. So, I think this review will really help quite a bit. I will also look in to see what formulas you're allowed to have. I will get back to you on formulas. I'll get back to you if I can get any more sense of how long it will be. It's a 2-hour test. So in the past, the paper 1510 tests have been around 25 questions, and each question might have 2 or 3 little parts to it. So I would assume at the most it would be is like, 50 one-part questions or 25 multi-step questions. I really don't know. If I can get any more information, I will. I'll send you an email, okay? So for Wednesdays, this coming Wednesday, here, let me stop my video.